Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. This is lecture number 6 in this course. We're going to talk about any questions you might have on assignments 1 and 2 first. Regarding assignment 1, until this morning, only one student submitted his assignment 1, and I think another 2 submitted after 4, like 30 minutes ago, before 30 minutes ago. So that's good, actually. It's good. So basically, it's just there's only one student left, and we discussed actually how to proceed with his assignment. So basically, if you can help him and show him how to get started, it would be great, actually, so that he can submit his assignment 1. Okay. For assignment 2, do you have any questions? The sound is very unclear. Can you try to? I'm not sure how you can do it, but it's actually difficult to understand what you're saying. Can you try again? It's not very clear. Can you write your question, or can you write it in the chat area? Because basically, I cannot understand what you're saying in. So anybody else has questions on assignment 2? Yeah, okay, you started assignment 2, but you still don't have questions now, right? Okay, that's fine. Okay, so next time, even if you have a question next time, we can discuss them, and if you need to delay the deadline, it's fine. Okay. So today, inshallah, we're going to start talking about research problem 2. I'm going to give you a general introduction to research problem 2. We're not going to code anything today. We're just going to talk about general. Just go ahead. Go ahead if you have a question. Don't worry about the deadline. Don't worry about the deadline, okay? Even if you submitted late, it will not be considered late, okay? Don't worry about the deadline. Okay, you can submit anytime. Okay, so the deadline is not an issue in this course. This is a graduate course. The most important thing for you is to understand material and do things yourself, and basically be able to use tools that you learn in this course in other areas. So this is the most important. The deadline, basically the other things like that, the other formal things like that are not that important in this course. So basically, as I was saying, I'm just gonna explain to you what we are going to do in research problem 2, and basically, from what I see, basically, we're going to spend the rest of this course on research problem 2. We're not going to take any research problem 3 because I don't think there will be much time left. And some of you are so late. I don't want to crowd them with another research problem in this course. So research problem 2 is very important. We're going to learn a lot of new tools in that research problem. And the remaining part, after we finish research problem 2, will be an assignment to read 3 papers. Okay, I'm going to assign each one of you 3 different papers, and I'm going to ask each of you to basically prepare a presentation for each one of these papers. And the presentation will be like 5 minutes. Okay, each paper will take 5 minutes. So each of you will have 15 minutes to present. Okay. The papers, I'm going to select the papers to make sure that, first of all, they are important from the point of view of learning how to write a paper. It's well written. The second thing is that it's not, it's basically, it's within the level of knowledge that you are at. You're not gonna, not gonna be assigned a paper with a lot of theoretical material that you don't have already. Okay, so basically it's just going to be a matter of applying what you learned to these papers and basically understand them, okay, and summarizing them. So basically it's just going to be, instead of having a research problem, it's going to be just like reading assignments, and I'm going to help each of you with his papers. So let's get started. We're going to talk about the topic that we were supposed to cover last time, which is an overview and ranking of scientific knowledge sources. Let me go to, I can, okay. So basically, whenever you get started on a certain topic of research, you have to read about this topic from somewhere, okay? What we're going to do now is to consider the possible sources that you can use in order for you to collect knowledge, okay? And they are so general that they can be applied to any field, basically. The sources that are available for any knowledge area range from books, popular and special interest magazines, professional and trade magazines, to scholarly and academic journals, newspapers, websites. Okay, each one of these has certain advantages and certain disadvantages and certain areas of information that basically they can provide. Okay, first of all, if you talk about the books, basically for books in particular, first one here. Basically, they have comprehensive information, they have background and historical information, they have a lot of bibliography. Do you know what the meaning of bibliography, this word? What does it mean? What is bibliography? References.
References.
A lot of references. Okay, so basically they are very useful. After we talk about the sources, I'm going to talk to you about where books should be in the hierarchy of knowledge. But actually, for books, usually, if you take a textbook, look at it, you will find comprehensive information. Basically, they cover the topic from all angles. Okay. We have background and historical information. So basically, if this topic started somewhere, they would tell you that it started somewhere, and this particular researcher started this particular technique, and they would tell you where it went from there and the difficulties. Basically, have a lot of information that are related to the knowledge topic that you are interested in, and basically they give it to you from a point of view of someone who saw the whole thing start and develop and then basically mature. Okay, so basically books are basically usually talk about things that are already well developed or mature. Okay, mature meaning that it has been around for a while. It's very difficult to find a new technique that was developed this year in a textbook. It will probably appear in a textbook like 5 years from now. Okay, so basically books are very good in covering a certain area. They will give you a very good start in certain areas, but if you want to get the latest in this area, you cannot basically rely on books. So the information contained in books would be historical context, meaning that basically they put the different techniques in a historical context, which came out first and which came out next, and so on. They have broad overviews. Basically, they give you a general overview of what's going on in a particular field, and it's intended for broader audience, meaning that reading a book is much easier than reading the specialized journals that are basically intended for specialists. So if you want to get started on a topic, it's much easier to start from a textbook rather than starting from a paper. Okay. The disadvantages include the dated information. Basically, sometimes information is late or old, a little bit older. The content level might not be very high, so sometimes it's if you are basically for someone who is going for a PhD, for a doctoral degree, if you want to get the latest and basically get very specialized in a particular topic, sometimes books are not basically the level is not really that high. So basically, it's not very high. Usually they have very general background so that so many people or people at different levels can understand what's going on. But actually it's very rare to find a textbook that has a high content level, meaning that it has the latest and has the depth necessary for someone who wanted to be very specialized in a certain topic. Of course, since it's written by a certain author, sometimes if this particular author has work in the area of the book, usually you will find that the book is revolving around the author publications. For example, if I wrote a certain textbook, okay, I already have a few, basically you will find that whatever I have in that textbooks, these textbooks basically talk about my work. You don't talk about the work, I talk about other people, but I emphasize my own work. This is called bias. Bias or slant, basically it's the same meaning, basically. It's the author, by definition, if I'm a certain author, if I'm working in a particular area, I'm very interested in a few topics in this area. I'm very interested in a few techniques in this area. I think these techniques are the most important. So basically my impression and my bias will come out in the textbook this way. So basically, if you look at the textbook, and this textbook is not generous in a particular area, and the author has certain publications in this area, you might basically get become aware that the information might have a bias from the author. Okay, so textbooks are very useful. I always suggest to anyone, at least in the master's level, whenever you get started, I suggest that you start from a textbook that is closest to the area that you're going to work on. Okay, textbooks are very important. And basically, you cannot have an undergraduate course without a reference textbook. So basically, textbooks are absolutely essential. So this is the first resource. The second one is the popular or special interest magazines. Okay, popular meaning that it's just like if you, for example, it's just a regular magazine that like the one you find in a bookstore. Basically, they are not scientific. Basically, they are general interests. Okay, or sometimes they have some special interests. Like for example, if you went to the U.S., you will find that if you went to a magazine stand, you will find at least 100 different magazines there. Okay, some magazines are interested in, for example, motorcycles. For example, some are interested in cats. Okay, some are interested in science. Okay, and basically there is a very nice journal, actually it's called the Scientific American. It's extremely nice if you want to get basically a broad overview and a simplistic introduction to a particular area. So they introduce science to the public, basically. Okay. The advantage of magazines basically sometimes they come out weekly or monthly or whatever. So basically they have current information. This is very good. So basically whenever something comes out, if basically a scientist discovers a certain new technique or a certain new species or whatever, you will find it there very quickly. The articles are short and easy to understand. They are intended for the layman. Basically, you're talking about the public. You're talking about someone who might not have a degree in science at all. Maybe he has a degree in literature, for example. He can still read about science through these magazines and understand them. They have lots of photos and illustrations, which makes it really nice. Okay, so basically, these are the kind of magazines that you can basically read in your leisure time and basically get some information along the way. The information there might include some long form stories, like a story about certain technique or a certain development, like robots or something like that. They usually discuss the impact on society. They are interested in discussing impact on society, what's going to happen when this becomes available, or when it becomes widely used, what's going to happen to the society. They have perspectives, like they can basically offer different or opposing views of the same topic, so that you can get the full information. And it's intended for the general audience, not researchers. Okay. The problem with such magazines, even though they are really useful sometimes, but they are not useful in the context of research, but it's useful to educate the public. The disadvantages include that the authors sometimes are not experts, meaning that sometimes the author just contacts people and gets their opinion and includes these opinions in the article. Himself, he's not an expert. It definitely lacks depth. It usually lacks depth, actually, not may. It usually lacks depth. And usually you don't get citations for resources. You don't really have bibliography there. It's not very common to read a newspaper or a magazine and find at the end, find a list of references where they use. They usually get their information from people and just quote them there. And of course, it's very important to know that they have editorial bias. Just imagine that in the US right now, they have a very deep divide between Democrats and Republicans. If, for example, Republicans have a magazine or a magazine that is run by Republicans, you would expect the information in that magazine to have a really large bias toward whatever Republicans think about. Okay. The other way around also. So basically, editorial bias is really major here. Okay, so these are basically like textbooks. Textbooks are very important in the academia. These are not very important in academia. It's basically like collecting general knowledge, but this is more for the public, not for research. So it's not a good idea to get started on a topic that was basically that you got from a magazine. Okay. It's not a good idea. Another type of magazines, professional or trade magazines. Okay, is any of you subscribing to AAMI, Association for the Advancement of Medical Instrumentation? This is one of the most important biomedical engineering societies. I really strongly recommend that you join that society because it has so much information that you can get from them. One of the things that they publish, they have a journal called BINT, Biomedical Instrumentation Technology. This is a professional magazine, meaning that it discusses in details professional and technical aspects of different things. Okay, different techniques in biomedical engineering. So basically, sometimes you have a topic or at least an article about, for example, ventilators, how they work and the problem in manufacturing them. Okay, sometimes they have discussions about the alarms. The alarms, there's a known problem for monitoring devices is alarm fatigue. Because basically, if you have systems that produce alarms very often, if you imagine that you have an ICU unit with 20 or 30 beds, and each one of the monitoring devices on each one of these beds would produce alarms every few minutes, then the people who work there will just go crazy, basically. And after a while, they desensitize basically against these alarms, and basically they become alarm fatigued. Okay, so basically they have topics about that. They have articles about that in such magazines. Okay, there are also magazines about electronics. Okay, like sometimes there's a very nice one. Actually, it's called EE Times. It actually introduces new circuits and new chips that are coming out from manufacturers, and basically gives ideas and applications how to use them. Okay, so these are really good. Okay, you have very specialized information. So basically, you can find some topics from there that can be actually very good and very practical research points. You have current information because also like magazines, they are basically appear very quickly. They appear like every month or something like that, and they have some bibliography as well. So it's very useful. So basically, whenever they have they have certain information that came out from a certain source, you will find that information as a list of references at the end of the article. So these are excellent, actually. Actually, for any biomedical engineer, I would suggest that you have to read this magazine every month because it's really good. It gives you perspectives about the current technology and also the future technology. What's coming out? What's going to be available soon? Okay, so basically, it's really nice. The information are in the information is in the form of long articles or reports. Basically, they put everything in context. Basically, when they say something, they have to put it in context when that particular technique can be used, and how and why, and so on and so forth. And they analyze its use. And basically, they are intended for professional audience. So, for example, this BINT magazine, it's intended for biomedical engineers. Okay, so if somebody from outside biomedical engineering would read this, you would find it really difficult to get the full information out of it. The disadvantages is that they vary between short, easy to lengthy, and specialized. Basically, they don't have certain formats. So sometimes actually within the same journal, you find that you have several formats. You have several kinds of articles in different lengths and different specialization. And sources sometimes not cited. Let me give you an idea and just try to find one of these magazines. I think I might have one here so that you can actually try to imagine how it looks like. I'm not sure if basically it looks like this. Basically, okay, this is not this one. This is another useful application, but actually this is not the one. Maybe this one. Yeah, this one. This is BINT. Okay. For example, right alert, right time. Develop clinically meaningful, actionable alarm notifications. Okay. This is the journal basically. Look at the topics. You have topics about research, about analysis. Sometimes you have departments like Frontlines or a Roundup. These are actually very short articles here, okay? And basically ask the commission. So basically some people send questions and basically are answered here. So basically let's just go through these and see how deep they can get, and few of the shorter ones, and basically see how they can get, okay? So basically, these are questions here. This is an article here, very short, and basically it's just answering a few questions. This is also the same thing. Here, basically, this is the main article here. So basically, you get in depth, you get some information. It's a lengthy article, as you see here, and at the end you have the references. Okay. Here, basically, you have other also. It's also a long article, so basically has references as well at the end. Let me show you some of the shorter ones. Okay. For example, ISO 13485, which is the quality standard for biomedical engineering, for biomedical devices. Okay, it's a very short article also, but it also has references. There are some techniques, for example, this one here, this is a really nice comparison between CPAP and BiPAP, which is basically two of the modes that are used in mechanical ventilators. This is a very practical article. This is very short, but very practical, because it's just 2 pages. Okay? Just 2 pages, this page and this page. Very short, but actually it's very informative. At the end, you don't have references. So basically, you have variability, basically. You have variable format like any other magazine, but it's extremely useful when you're trying to basically find real problems, real ideas for research that are related to practical problems that people are discussing in reality, in actual work, okay, in professional practice. It's not like theoretical problems or anything like that. These are all practical problems, and basically they report the problem, they report the solutions, and they report also the future directions that people are thinking of to try to solve these problems. So these are really useful. Okay, is it clear? So this is actually the professional and trade magazines like this one here are very useful. I actually, basically, maybe I can just designate it just for you to be, I'll just put a star here. Basically, this is one of the best resources to find good problems, good research problems. And as a professional engineers, it's important if you want to keep up to date in your field. I would suggest to find a magazine, a professional magazine of this sort, and keep track of whatever happens in your field through it. Okay? Sometimes you can actually publish. Sometimes if you have a problem in your hospital, if you're working in a hospital and basically you found a problem and you try to solve it and ended up with mixed results. Okay? Some things are good, some things are bad. You can actually report that in a magazine like this. Okay, so this is a very good resource for us, for research and for professional practice. The next resource is the scholarly or academic journals. This is basically, if you talk in the academia about a journal, this is what he meant by journals here. Scholarly or academic journals, like IEEE journals, like many journals that you find in many places, like Springer journals, like Wiley journals. They have certain publishers, and these publishers have journals in very specialized fields. You'll find, like, for example, for biomedical engineering, you will find journals about general biomedical engineering. You'll find journals about medical imaging in particular. You find sources about, or journals about computer applications of biomedical engineering. You have bioinformatics, for example, medical informatics, things of that sort. Okay, so basically journals are very specialized, and since they are specialized, they are intended mainly for basically they have depth, and they are intended, they are written by experts and read by experts also. They are basically, if you read a journal paper, which basically is going to be the last part of this course, you read 3 papers. Basically are not intended for the layman. They're not intended for the general audience. They're intended for people who are experts or are working in this particular field of the journal. Okay, we have charts and graphs. We have much less pictures. You don't have as many pictures, and like here, for example, the magazines here. Here you might have some pictures and things of that sort, and photos. Here it's usually charts and graphs, like the ones that you did in assignment 1. It's usually recent research, but actually I'm going to have a comment about that. It's recent, but not recent, meaning that it's not last month. It's probably last year or earlier this year. It's not really that up to date as this one here. Here, we call it current. Current meaning that it happened last month, for example. Here, recent, it's probably within a year from the date of publication. And it definitely has bibliography. If it doesn't have bibliography, it will not be accepted or published. So these are very strong advantages. They are very important for anyone who is going to do research. In fact, at this university, you cannot graduate without publishing at least 1 paper for the master's degree. The information often are theoretical. They are peer-reviewed. Peer-reviewed meaning that it's not just the editor who reads the article and that's it. No, it's sent to several people, and basically these people are experts in the field. They review everything, they make sure that everything in the paper, everything that was mentioned in the paper is correct. So this is called peer review. Peer meaning that a colleague, okay, someone at the same level as the author, okay. So peer review meaning that if I send the paper, okay, it would be sent to another 2 professors somewhere else. I don't know of them. It's blinded basically for me. I don't see who's reviewing my paper. But these reviewers send me a list of comments they have. These comments might be things that are incorrect, things that are not clear, things that might need improvement, and I have to respond to all of them. It's very common to have a very long list of comments from such peer review, and it's okay for the author to still basically write a response letter to each one of them. And if the editor sees that your response is proper, if somebody, for example, told you that your paper is incorrect, and you responded to prove that it is correct, okay, that's fine. The editor can basically say that, okay, I'm convinced that this is correct, so I will accept that one, okay? So this is one of the things that also we'll probably have to talk about. This is one thing that I have to talk about with the recent research here. And usually have a very narrow focus. So it's not like I'm going to talk about ventilators. No, I'm going to talk about how to design, for example, the control mechanism for the CPAP mode in mechanical ventilators. So it's very specialized, okay? I'm not talking about here for journal papers. Don't expect somebody to talk about MRI, for example, okay? So basically the article will be MRI, okay? No, basically I have to talk about a very specialized topic in MRI so that I can have a contribution. And this is how science progresses. Each small part of each technology is advanced through papers like this. So it's very narrow focus, and basically that's why it's very deep. Usually it's written by scholars, researchers, professionals, and students, and it's actually intended for them, okay, for similar people. So it can be written by people who are basically well known in a certain topic, like a scholar, or just a researcher. You are a researcher right now since you are registered for a graduate program, so you are a researcher. It's intended for professionals, people who are working with this technology in practice, and students meaning that the postgraduate and undergraduate students. The disadvantage of scholarly or academic journals, it has very specialized terminology and it's very deep. So unless you get used to the specialized terminology and basically have enough background to basically understand the depth of the paper, it's going to be really difficult for you to read the paper. Okay, you're going to practice that yourself. Okay, and dated information, sometimes the papers are not very recent. Okay, meaning that if it's a year later, it's a problem. Okay, sometimes in some fields the progress is very quick. If you're talking about something that was a year ago, it might be an old information. So basically, sometimes the information comes out after it's a little bit late. So this is definitely one of the important sources that you have to have, but it has some limitation. I'm going to talk to you about it in a second. Okay. Newspapers, these are like OCAs, like whatever. Journal is just a newspaper. Okay. Sometimes in a newspaper they would discuss, for example, ventilators. Like when COVID-19 came, the people just talk about what ventilators are, why they are used, something like that. These are very general information. They are of very little interest to us as researchers. A very important source I would like to talk to you about, because some people actually confuse it or basically use it improperly, which is websites. Okay, sometimes people think that websites have information that is correct. No, it's not like that. Websites, I have a website, okay? I can go on my website right now and put up a page that talks about the Earth as a flat surface. I reject the theory of spherical Earth. I put a theory that the Earth is just a flat surface, and it's like a rug flying in the sky. Okay, I can put that on my website. Okay, and basically nobody reviews what I put on my website. Since nobody reviews what I put on my website, I can put anything. So the information on any website, they are not usually very reliable, at least in the research part. Okay, so don't rely on that. Don't rely on information from websites. Sometimes if you talk about different websites, they have various points of views, which is okay. You have, if you search about a certain topic, you will find so many different things. Some things are wrong, some things are right, and some things are basically emphasizing certain aspects. Some people are de-emphasizing these same aspects. Basically, you have a mixed bag of information, which is good, actually. If you are a good researcher, you can actually pick the right thing out of them, but you don't rely on one source. You have to actually look at all or many resources, at least many websites, so that you can get the right information. Sometimes the websites have statistics which might be useful in some research problems, like usage information, like for example, if you want to have, for example, the percentage of people or mortality rate of COVID-19 in a certain country, you'll find that on a website. You're not going to find it in a journal or a textbook. Okay, if you want to get the up-to-date information. The most important thing that you can rely on in websites is industry information. For example, I wanted to work with Arduino, for example. Okay, there's a website for Arduino. This is okay. This is acceptable. This is basically, this website will have all the information that you want. So this is important. This is acceptable. If it's an industrial entity like Arduino, like Texas Instruments, like analog devices, whatever the components manufacturing companies, it's fine. I can actually, like Intel, like NVIDIA, whatever, you'll find some technical information that are okay. You can, if you're looking for a technique, if you're working with Arduino and you would like to do something in a particular, you can find that information on Arduino website, and it's fine. It's going to be okay. It's going to be reliable to work with. Okay, but this is a special case in the websites. Okay, so if you're looking at an industrial website, you can actually find the who, what, and when, and where of an. Sometimes this is probably general, but actually, if it's industry information, this is probably not enough. Basically, you find deep information. If you want to, basically, for example, for Arduino, you can find programming tips. You can find even code that you can use directly to solve your problem. So basically, it can be very useful. Okay. The issues or disadvantages is that the credibility and accuracy cannot be assured. I'm talking about the general websites. For the industrial website, they are okay. Information may be biased. This is definitely correct, even for industrial websites, because, for example, if I have a technology from TI and technology from analog devices, these are competing devices. Okay? So basically, they tend to emphasize their product, and these tend to emphasize their product. So basically, you will find conflicting information that is coming from bias. So you have to always keep thinking about bias, okay? Because whenever somebody basically produces a piece of information, his own bias will be there. So you have to basically put every piece of information into perspective. Usually in websites, it's very unlikely to find sources. You don't really find references in websites, but actually sometimes if you're talking about some of the industrial websites, if they are using a certain technique, usually they would put a textbook or a paper or whatever that would describe the technology that you are using. Okay. There is another resource. So basic websites are basic. I suggest for websites at least, don't use them only or use them only for industrial information. Okay. There is another resource called conference proceedings. Conference proceedings basically Like, for example, sometimes they have an IEEE conference on biomedical engineering every year. This conference, people come and present their research or the preliminary version of the research, and basically people ask them and people suggest things to them, and basically this is the first basically first maybe I can say first version of research, meaning that if I'm going to develop a CAT system, if I'm going to develop arrhythmia detection, which is computer-aided diagnosis system, okay? For example, I tried a particular technique and it worked. It looks like it's working, okay? And I would like to basically say that I did this work so that other people know that I did it, and I claim the intellectual property rights for it, okay? It's very difficult to write a journal paper because they ask for a lot of things. So in conference proceedings, you just write the summary of what you found, and it would be acceptable because they usually ask for a very short paper, and they just need a new idea. They focus more on the ideas than the verification. So basically people publish their first version of research in a conference, and this comes out in a conference proceeding, like a conference book. It's a form of a book, okay? But actually it's called Proceedings, and it's usually available through, if you have the digital library, the University Digital Library, you will find so many different resources where you can find such proceedings, such papers, such conference proceedings, like IEEE, like Science Direct, like Wiley, and so on. Okay, so after the first version of the paper is accepted, you move on to publish it as a journal form. In a journal paper, okay? So this is a conference form, okay? Basically it's short, and sometimes it's incomplete. And basically this is long, complete. Okay. One very important thing about conference proceedings is that they are basically current. Basically, they appear here maybe a year before they appear in journals. So if you want to follow what's going on in research in a particular area, I suggest that you look at conference proceedings rather than looking at journals. Journals will have the complete information. The technique will be well developed, well validated, okay? But if you want to continue working on a certain topic, or if you have a certain journal paper and you're wondering if somebody did something after that journal paper, then you have to look for conferences and see which, whether there is another paper that came out after this work and has an addition to it. So conference proceedings are really important. They are not as rigorous as journals, meaning that they might not have, they are basically incomplete. Some things are not very well tuned. They are not optimized, but they have the ideas that you're looking for. Okay, so this is really important. Let's go back to the things that I told you about here, about the academic journals. Basically, let me have it in another, or here maybe. Okay, very important notes. Here at the university, every student is required to publish a paper. Okay, it can be any one of these. It can be a conference paper, it can be a journal paper, whatever. Most people publish journal papers. You know why? Why would a student who wants to finish very quickly, basically wants to finish in a year, maybe to do a thesis in less than a year, why he would go for a journal rather than a conference. Conference, actually, you can get a conference paper published much earlier, much easier than a journal. Why would you go for a journal paper? What? Okay, let me give you a hint. Okay, journals are basically not the same. Okay, you have authentic papers, and you have something called predatory journals. Okay, basically the authentic or the real journals, basically everything I said before was about real journals. There are predatory journals. Maybe I can put this terminology. Okay, and publish. Okay, pay and publish. You pay $60. Your paper comes out the next morning. Okay, so basically you do not have any peer review at all. You just pay and publish. Okay, very simple. Okay, usually this is basically most of the journals. If you look at your colleagues who graduated from this university in particular, unfortunately, most of them publish here. Okay, they pay $60 and gets accepted in a week, in less than a week. Okay, these journals do not have any weight. They are not scientific. You can write whatever you want. I can write a paper about the flat Earth theory, okay, and it would get accepted there. Okay, I can basically write a paper about basically generating energy from vacuum, okay, and it would appear there. Okay, I would write a paper about a cure for cancer, okay, and it would get accepted and published there. Okay, you can basically, nobody looks at what you have. Nobody looks at your paper at all. You can publish whatever you want. Okay, unfortunately, basically it seems a little bit defying the purpose when you're requiring students to publish papers and let them or allow them or accept papers that are published in such journals that it's really it's basically for me I cannot understand it basically. Okay, but this is the way it happens here. And in some courses also, probably took some of these courses before, you're required to publish a paper in such journals. Okay, in order for you to finish a course. Okay, so basically this is just ridiculous. Actually, it doesn't make any sense. I'm talking about this now because if you do a search, okay, usually when you do a search, you go to something like Google Scholar. Okay, when you do that, you will find so many papers published in such predatory journals. Let me try an example for you right now. Google Scholar. As it's, for example, computer aided diagnosis. Okay, this is Google Scholar here. Okay, basically, if you go to the journals that you have here, okay, here it's Elsevier. Usually, it's a good publisher. So basically, this is a good journal. This is IEEE. This is also a good journal. Okay, here BMJ, British Medicine Journal. This is also a well-known journal, so it's okay. This is Elsevier also. This is the same thing. I'm trying to see something that is not a good journal. Okay, maybe I can just have since 2020 so that you can get suddenly everything is authentic now. But actually, if you look for some reason, all these are good journals. For some reason. Okay. Okay, here for example, okay, Research Square, okay, researchsquare.com. This is not a good publisher. Okay, so I'm not sure actually why this is actually not a good journal. I can't find many actually, but the CSV.com, I'm not sure about also if this is a good journal. In general, I suggest whenever you're looking at a particular journal to publish in, if you want to publish in an authentic journal, sometimes people confuse such journals with the authentic ones. Basically, look at something called Scopus. Okay, Scopus, basically if it's Scopus, if it's present in Scopus, then it's usually a good source. Okay, sometimes you have what's called Web of Science. If it's listed on Web of Science, then it's okay. Usually, if it's in Elsevier, it's okay also. If it's in Wiley, then it's okay also. I suggest if you have a certain journal that you're not sure of, you consult your advisor, your supervisor, your advisor, your instructor, whatever. He will tell you that whether this journal is okay or not. Okay. Usually, the predatory journals basically usually start like International Journal of whatever. Okay. And sometimes they have a name that would indicate that they are coming from America or Britain or whatever. So American Journal of Biomedical Engineering, it's not a good journal actually. Okay, so basically sometimes they insert international or American or whatever to basically try to fool you or fool anybody else to just think that this is a good journal, but actually it is not. Okay, so journals, you have to be really careful about predatory journals. Authentic journals take a long time. If a journal tells you that your paper will be accepted in a week, you have to be sure. Basically, actually, it's almost certain that this journal is not an authentic journal. For a peer review process, because basically they take your journal paper, if you send it to an authentic journal, they take it and they try to contact certain researchers that are in the same field, and they wait for them to respond, and these reviewers will take time to review paper and then send a recommendation to the editor, and the editor considers them and then makes a decision and then sends it to you. So basically for an authentic journal, in order for you to receive a response, not acceptance, response, okay, with comments and things like that, okay, it usually takes a few months. Okay, sometimes actually in some journals it might take a year to get a response. Okay, so if somebody tells you that you pay this and publish tomorrow, or you have a guaranteed publication when you pay, you're sure that this is basically not an authentic journal. Okay, are we clear on the resources that we should get our information from? Basically, textbooks are essential. Professional or trade magazines are really good. Okay, not many people, by the way, in the research community look at them, but actually, if they do, they can generate very good research problems that are practical and useful. The scholarly and academic journals, basically the authentic ones are really good. You have to actually read them in order for you to do research in any topic. And please add to that the conference proceedings and the websites. If you work in a certain technology and you would like to have some industry information, then you have to use websites. Please do not use websites for research. Like for example, if you read an article on a website, it's not a very good idea to basically rely on it on your research, because basically websites are not reviewed. So whatever is written there, nobody looked at it and confirmed that it is okay. For conferences and academic or scholarly journals, they are reviewed, they are peer reviewed, they are basically checked by people before they appear. So the information there is much more reliable. Is that clear?
Yes, Professor.
Okay. So this was a topic that we were supposed to talk about last time. Now I'm going to go over the research problem 2. Okay, which is automated ECG arrhythmia diagnosis. Okay, in order for us to understand what we're talking about, basically I placed the data for the second topic. Actually, when you basically it's a RAR file. When you open it, you will find these files in there. One of them is data reader. I'm just going to run the data reader so that we can see how the arrhythmias look like. Okay, so basically we have 4 types and 1 in addition of the 4 types. Okay, I'm going to tell you why I separated the 4 and the 1. Okay, so this is the normal ECG that we're used to. Okay, and this is what's called ventricular couplet. This is ventricular tachycardia. This is ventricular bigeminy, and the last one here is ventricular fibrillation. Okay. The reason why they are separated because the sampling rate is different. Okay, each one of these samples is basically represents 3 seconds of ECG. Okay, so 3 seconds. The sampling rate here is 360 samples per second. So 360 times 3 is going to be 1,080 samples. So all these are 1,080 samples. For the ventricular fibrillation, the samples were actually collected at 250 samples per second. So it means that for 3 seconds, you get 750 samples. Okay? So basically, the idea is you're going to have many samples of these. We have basically, I placed for you several samples for training and for testing. We're going to try to learn how to characterize each one of these, and basically we're going to develop a system. When you present it with a particular type of ECG, it will tell you that this is supposed to be normal, or this is supposed to be abnormal, or whatever. Okay, so basically we're trying to develop a computer-aided diagnosis system. This is not a very simple task. Sometimes people think that if I know how the ECG looks like, this is a normal ECG, I know how it looks like. So basically anything that doesn't look like that should be abnormal. But the problem is you have variations of this. So for example, imagine that you're trying to, basically this is one normal ECG. Okay, the other one might have a different rate, meaning that the first one will come out the same way, but you actually have a different rate, like come out like this. It actually, each one of these looks alike, but actually have here several ones, basically more than these ones, because of the rates. You have different rates. You have a different phase, meaning that you might, the ECG, the first one might start here, the second one, the same QRS will start here. They're not synchronized, basically. Okay, so basically you cannot compare, you cannot directly compare them. Okay, in order for us to compare them, we have to consider several things. If I wanted, for example, let me give you an example that is not related to this problem and just try to basically understand why we're doing things this way. If I wanted to compare for example, success rates of secondary students. Okay, how to compare the success rates? Okay, if I have, for example, 100,000 students, I have grades for the 100,000 for year 1. And for year 2, you have also 100,000. Might have actually, might not be 100,000, might be 120,000. Okay, you have their grades. How do you compare them? Can you give me an answer? If I wanted to compare the results for students from year 1 to those from year 2, do we directly compare student number 1 by student number 1 from year 2? So student number 1 year 1 to student number 1 from year 2, and student number 2 from year 1 to student number 2 from year 2?
No.
How do we do that?
We need to scale the size of the sample.
Scale the, how do you do that? You have 120,000 students. How do you scale the students? I mean, it's a student has to be a student, right? You cannot scale a student.
Yeah.
Okay, so how I mean, how do you compare them together? Basically, you look for what's called statistics, right? Look at the statistics. You look at the mean and standard deviation here, and the mean and standard deviation here, right? If I get the mean and found that the mean here is higher, for example, the mean here was like 80%, the mean here was like 75%, I can say that the students in year 1 had higher success rate than the students in year 2, regardless of their number, right? Does it make sense to you?
Yes, right.
So basically, the statistics, the parameters that we're talking about here, these are features, what we call features, okay? Meaning that sometimes it doesn't make sense to compare things right away. So basically, if you try to compare things, if you try to compare these two directly, it doesn't make sense because there are so many variations that you can find. Variations, rates, and phase. Sometimes you have variations in amplitude. And usually the QRS, they have variations in shape also. These are normal variations, normal people variation. I'm not talking about pathological variations. So basically, it's extremely difficult to find, basically compare things point by point. You have to basically think about certain features. And basically, these certain features can be compared directly regardless of how the shape would look like. For example, if I compare the rate here, you have here 3, here you have 4. I actually have, for example, the rate here would be like 70 beats per minute. Here, the rate would be like 90 beats per minute. Okay, I have a range for the normal between 60 and 100. So both these are normal. This is the normal range. Right? So basically, these are the kinds of things that we're going to do. Basically, what we are going to do is, for each one of the signals that we have here, we're going to develop a set of statistical features, like descriptors, like quantitative descriptors of the shape, of how these look like, and basically try to compare them between different classes, and try to find whether basically we can compare them, or whether which one of these would be more suitable to discriminate between the different types of ECG. Okay, so features are like, for example, if you're comparing people, okay, if you, for example, you want to hire an engineer for your organization, for example, okay, you basically ask for the CV of the applicant, or you have a form that the applicant has to fill out. Okay, so basically, if you consider this problem, okay, you want to hire an engineer to work on medical devices. Okay, each one of the engineers is just a human. Basically, you can develop a certain features for each one of the engineers that are applying. Okay, for example, the degree. that he has. Okay, basically you can actually ask about things like personal things like marital status.
Experience.
For example, yes. Experience. Maybe you can ask about color of the eye. Okay, so basically, if I consider any engineer, these are certainly features. Basically, each one of these would describe this engineer. Okay, so for example, for engineer A, if his eye color was like brown, okay, and engineer B has a black color of eye, okay, for example, okay, you can discriminate between these engineers in terms of the color of eye. But actually, would that be relevant to the hiring process to work on medical devices? Probably not. This is not. Marital status, probably not also. Okay? So basically, the degree would be very important. The experience would be very important. Okay? So these are features. Okay? But we have to do something called feature selection. Meaning that if I, for example, took the ECG signals that I just showed you, computed the mean for each one of them, okay, computed the mean, and found that the mean in all of them is almost the same. Would the mean be a useful feature to discriminate between them? Probably not. Okay, so basically, after I propose a certain set of features that describe the statistics of each one of these signals, I'm going to have to do something like feature selection where I check each one of them. And we're going to check each one of them using a particular statistical test. Meaning that basically if I have a certain feature and found that this feature, for example, I'm considering a particular feature, okay? Feature number 1, or feature A, without describing what this feature is. And I found that this is basically the scale of the feature. This is the range of the feature. Okay. This is feature A. Okay. And this is basically the values of this feature. And I found that I have two classes, class 1 and I have class 2. I have two classes. I'm trying to find whether the ECG is normal or abnormal. And I found that the samples or the values from class 1 were here. Okay, and the values of this feature for class 2 were here. Would this feature be useful, in your opinion? Let me make it simpler for you. How about this? Would this feature be useful?
Yeah, it's useful
Why?
because we know region of each type of the
Yes, exactly. Basically, we can come here and basically place a line right there, right? And say very simply that this is here class 2 and this is here class 1, right? Very simple. Okay, if the features were like the one I had before, how about that? Would it still be useful?
No.
Actually, it is. Actually, it's very difficult to find separation, complete separation like the one that we saw. It's almost impossible, actually. Okay, so basically, let's just move them. Okay, this is an ideal scenario that you will never find. You will never find, I assure you. What you will find is something that looks like this. Okay, and basically, if you have a separation here, if you look at the mean, basically, if you look at the cluster where the class 1 samples resides, like for example, if you just have this as a cluster like this, and put another one for class 2. Okay, do you see these overlap? You don't really overlap, yes, but they do not overlap in a very large area, just a small area. So basically, if it's like this, then it's acceptable. It's not perfect. It's not going to give you 100%, but actually you need a feature like this and another that has a different overlap, and the third and the fourth and so on. And together, it will basically have the separation. But this is acceptable. When would it be unacceptable? When it becomes like this. If I have values it's like this. Basically, we try to see the clusters. Basically, one of them would look like this, and the other one would look like this. They are intersecting in basically major area of each one of these clusters. So basically, this is not acceptable. So basically, this is acceptable. Acceptable features, this is not acceptable. Okay, so these will actually, we might do some simulations at the beginning, inshallah, next time, so that you can understand these. And we will try things so that you can understand how basically we're going to do that with simulation, so that exactly how they look like. And then when we go to the real data, we cannot see that. We have to test them with the same tools that we're going to basically develop through the simulation. Okay, so basically feature selection means that I separate the features that are acceptable from those who are not acceptable. The features that are not acceptable do not have variations between classes. Like for example, if I tell you an example of a feature that is not acceptable, for example, let's just have the example of eye color. Discriminate between, for example, men and women. Can you discriminate between men and women in eye color? So if the eye color is so, then it has to be a man, for example. Very unlikely, right? Very unlikely. Or maybe we can just, instead of men versus women, maybe you can just say that normal ECG and ventricular tachycardia, for example. So if you basically look at the eye color of the patient, will it tell you anything about this? Will it tell you anything about whether the ECG would be normal or has ventricular tachycardia, for example? Very unlikely. Eye color is definitely a feature, okay? Basically, if you describe a person, then you will say that this person is looks so and so, and his eye color is so and so, and it's a definite feature of that person. But it does not have any relation, it does not have any relevance it's not important or basically a discriminating feature. Maybe the word is discriminating. It does not discriminate between the different classes that I'm interested in. Maybe it's in another thing. Maybe it's in another classification problem, but it's not relevant or discriminating in my particular classification problem. Okay, so basically, maybe eye color is a good feature if you're trying to compare people from Africa and Europe, for example. Okay. Maybe the eye color basically can discriminate. You can basically detect whether this person has an origin from Africa or from, for example, Sweden by just looking at the eye color. Okay, but related to the problem of ECG classification, it's irrelevant. There are statistical features that look very good, okay? And you'll find that they are very useless, actually, when you try to use them in classification problem like this. So we're going to develop tests, we're going to develop statistical tests that would allow us to do that, would allow us to basically discriminate between or detect the features that are discriminating or not. Okay, so our first goal will be to develop features without thinking about whether they are useful or not. Then we're going to pass them through the filter of statistical testing. Those who pass the statistical testing, who prove to be discriminating, will proceed further to basically be used in the classification. Okay, so inshallah, from next time, what we're going to do is basically simulate features, and then see whether these features are useful or not using the statistical testing, and then do classification of these features. Once we do that, we know the origin of these features, and basically we know how things are going or how things are done. And basically when we get used to the process or the pipeline where we do that, we're going to move on to use the same features and the same testing and the same classification on ECG. Okay? So basically in this feature, maybe you can just go and read the what the research problem is about. First of all the samples that are given in this research problem are coming from ventricular arrhythmias. You do not include atrial arrhythmias. You know, the heart has two atria and two ventricles. The ventricular arrhythmia are arrhythmias that originate in the ventricles, not in the atria. Okay, because you know that the regular ECG should come from the pacemaker in the sinoatrial node. It's in the atria, and basically it propagates through the muscles of the atria, and then it goes into the atrioventricular node, and then it propagates from there through the muscles of the ventricles. Because the ventricles are responsible for pumping the blood to the whole body, so basically they are much more important in terms of their irregularities. If you have irregularities in the ventricles in particular, it can be life-threatening. So all these ventricular arrhythmias are selected because they are life-threatening. Okay, so they are extremely important to detect early on. One of them, which is ventricular fibrillation, is basically deadly. If it's left unattended to, the person will die within a minute or so. Okay, and that's why we developed the defibrillators. Basic defibrillators is basically removing ventricular fibrillation. We're trying to deal with ventricular fibrillation. Okay, so that's why we have all the 5 types that we have, or the 4 types in addition to the normal. All of them are ventricular arrhythmias. Okay. The importance of the arrhythmia detection problem is that you usually have a large ward of, usually intensive care units have so many different beds, and basically it's very difficult to keep track of all of them. So sometimes it's not basically, if the patient is not attended to, might develop an arrhythmia. And if nobody's detecting this arrhythmia or looking at his ECG, he might actually die within minutes without people even knowing about it. So basically, having an arrhythmia detection in monitoring devices is very important to at least detect the first signs of arrhythmias so that they can be treated early on. Okay, so we're going to attempt to build our own computer-aided ECG diagnosis. Basically, the data set we have, as I told you, we have normal, we have ventricular couplet, ventricular tachycardia, ventricular bigeminy, and ventricular fibrillation. Each one of them has several samples. Basically, in order for us to build a computer-aided diagnostic system, it's like basically teaching a student. Okay, you have to teach the computer how to do that. In order for you to teach a student, you have to give them examples. Okay, this is, for example, this is type 1. Okay, like, for example, if you're teaching a kindergarten student, okay, you will tell them that this is called this and this is called that. Okay, and you show them different examples so that if you have an apple, for example, you have different kinds of apples so that you can actually show the student that basically all these are considered the same kind. Okay, so we need to have learning signals so that we learn from them how each one of these different types looks like. And we basically have another signals that are separate from the learning signals that are called testing signals. Okay, these are like the tests for the student. For example, if you have a student, if you're teaching a student a particular type of math, okay, for additions, for example, okay, if you teach a student how to do 2 times 2, okay, and basically keep doing that for the whole term, okay. If you come to the exam, if you put a problem 2 times 2 equals what? Actually, the student would write the answer without even thinking because basically he saw it before. If you want to test, if you really want to test how or whether the student understood exactly what the multiplication does and how it can be done, you have to have a different problem. You have to have a problem in the exam that is different from the examples that you showed the student during the learning process. So you have a different and independent signals for learning, and you have different and independent signals for testing. Okay, all of them have the same length. We have to have certain standardization. You cannot compare signals that have different lengths. So we compare signals of the same length so that we can detect different features. Or basically, we cannot compare if you have a signal with 100 points and another signal with a million points. Okay, if you try to compare the energy, okay, which is basically the summation of the square of all the points, then you will have a difference between the two that comes from the number of samples. We don't want that. Okay, so basically we need to standardize the duration of the signal. Unfortunately, sometimes the signals during the same time, they have different length because they are sampled at a different sampling rate. Okay, so basically we have to do something to basically readjust the sampling rate. We're going to see how to resample the signals. So it's a very simple technique. Actually, I'm going to explain it to you. And basically, we're going to convert all of them to the same before we start. And then we start, later on, we start to think about features. They will come from statistics. Basically, they will include mean and standard deviation, things of that sort. And we're going to basically tell you about a few other things. And basically, after that, we're going to do feature selection. So select which features are relevant to our problem. And then basically, we're going to do classification. Classifiers, basically, they are part of machine learning, which is under the umbrella of the present day buzzword, which is artificial intelligence. And basically, machine learning is a part of it. So we're going to learn a little bit about that. I'm not going to go into any further details this lecture. I just wanted to give you an overview of the search problem 2. And from next time, we'll go out with simulations. so that I can give you a chance to finish assignment 2 before we can get started on assignments related to research problem 2. Do you have any questions about research problem 2? Basically, this is a very general introduction. We're going to explain each one of the particular parts of this research problem when we get to it. Do you have any questions? Okay, so if you don't have any questions, I think I'm not going to talk any further, because actually if I basically go on a little bit more, it's going to be basically, I have to go into some details that will basically, I don't want you to get into any new material today, so that you can finish assignment 2. So we'll continue next time, inshallah. Then I will wait for a question, please. If you want to have any, if you actually have questions, I want you to answer them. I want me to answer them. Please let me know, and I can arrange for a meeting with you. Okay? You don't have to wait till next time. Okay?
Okay, doctor.
Okay.
Okay. Good luck, inshallah. And I will see you next time, inshallah.
Inshallah. See you.
Okay, thank you. Assalamu alaikum.
Thank you. Wa alaikum salam.
Salam.